In this module, we'll talk about a specific kind of memory corruption that is used by attackers to compromise computer systems. It is known as the buffer overflow. And we'll start with the very basic overview of buffer overflows. What is the general idea? And then we'll gradually make it a little bit harder. Buffer overflows have been around for a long time. They were already discussed in a US Air Force document in the 70s. And they were famously used in many attacks, including the first internet worm, or the Morris worm, which was written by Robert Morris Jr. in 1988, and which, as they say, brought the internet to its knees. That is, all the computers that were infected, which was pretty much all of them that were connected, had to be turned off. Okay. So the buffer overflow, despite its long history, is still very, very actively used. In fact, it's still every year in the top 3 most dangerous programming errors as published by the SANS Institute. Okay. Even today, it is one of the most important weapons that is used by the attackers. It is used in attacks such as drive-by downloads and other very dangerous attacks that allow attackers to get complete control over a computer. The other characteristic of buffer overflows is that they are extremely simple. Right? Everybody can understand them. Everybody should be able to recognize them and avoid them. Right? At the same time, we can make very advanced versions of them, and with current countermeasures, we may have to do so. So it's actually an ideal vulnerability. It's important, it's easy to understand, and it's relatively easy to avoid. So what I'm going to do in the remainder of this series of lectures is I'm going to talk about the buffer overflow, not from a historical viewpoint, but from the general idea. What is a buffer overflow? How does it work? There are a few things so annoying as newspapers that tell us that there is a bug, a security hole, or some other problem in modern software, in a browser or in Windows or what have you, and never bothering to explain what that means. So why is this vulnerable? How could attackers make use of a security hole to gain control over a program? So this is what you'll learn in this module. And I'll start with the very basic way in which computers operate so that you can see it from the very beginning. And then at the end of that part 1, I'll show you a stylized buffer overflow. In the entire first part of that module, we'll use a toy processor, something that is just used to illustrate the processes, but doesn't actually run Linux or anything like that. It gives you an idea of how it works. Everybody should be able to follow that. After that, we'll switch to a real buffer overflow, something that actually runs on modern operating systems. Okay, so you get real code, real CPU, and a real buffer overflow. And after that, we'll get to the more advanced stage where we'll look at the countermeasures, the measures that are used to stop buffer overflows. We'll look at stack canaries, data execution prevention, and address space randomization. So the first part should be accessible to everyone, not necessarily computer scientists. The next part should be mainly taken by computer scientists. And the last part is perhaps more suited for anybody who's actually studying security, maybe taking a course on security.